welcome back to my channel. Today we are going to do a video about Tinkercad circuits, quad and gate. We are going to see about AND gate and we are going to do one program with AND gate. AND gate. Now this is an AND gate. First of all, I will explain, then I will do. This is the project which we are going to do in Tinkercad. First, let's see. This is an AND gate. There are more gates like AND gate, like OR gate, NOT gate, etc. This and we are just going to need to see about AND gate. Now, what are AND gates? Logic. They are like logic gates, and let me tell you about them. Logic gates are the basic building blocks of any digital system. It is an electronic circuit having one or more than one input and only one output. The relationship between the input and the output is based on a certain logic. Based on this, logic gates are named as AND gate, OR gate, NOT gate, etc. AND gate and Tinkercad. This is a logic diagram. This is a logic diagram. You can call this an integrated circuit, IC. This integrated circuit, this is the logic diagram of the integrated circuit. Now, there are two pins called A, B. There are two pins, like this is pin A, pin B, and this is Y. Y means output. This is output 1. Now, quad and gate. Now, what does quad mean? Quad means 4. There are 4 sides. Now, there are 4 output and 4 and 1. Now, there are 2 inputs here. 2 inputs here, 2 inputs here, 2 inputs here, output, 2 inputs, like that. Like this is an input A, input B, and this is in output 1. And then it is input A, B, and then it is output 2. Like that, it goes here too, like that. Y means output. A, B, input A, input B. This is an logic diagram, and this is an truth table. Now, in this truth table, in this program, this is here. I already did it. Now, I only need 2 of these scissors. This is an this is an different Swiss. It has 4 scissors. I'm just going to use 2 scissors. Now, in this logic diagram, it tells if 2 of these are off, if 2 of these scissors are off, the light bulb should not. The light bulb will be off. And if one scissors, this switch is on, this switch is off, and this switch is on, it won't work. Then if this switch is off and this switch is on, it won't work. Only if this switch and this switch are on, then the light bulb will work. The light bulb is the output and the switches are the input. That is how the truth table works. See, the input. That is how the truth table works. And in this project, we are going to need 6 components, and those are power supply, IC integrated circuit, light bulb, switch, scissors, and breadboard. 6 components. and there's a lot of wiring, and also resistor is also wiring. The color has to be correct. The color in this wiring you can choose any color. Now let's go to Tinkercad. Now we are in Tinkercad. Let me explain about this circuit diagram. Then I will do this without seeing. Okay. Now the first step of this program circuit design is, first we have to connect the power supply to the breadboard. How do we do it? Let me show you. Connect the power supplies positive to the breadboard plus anywhere here, and connect the power supplies negative to the breadboards minus anywhere here. This is horizontal line, this is vertical line. Then from the minus of the breadboard, which is here, you can from here you can connect with anywhere. From here I have connected it to the top of the breadboards minus here. From the bottom minus I have connected to the bottom minus to the top minus. Then from the plus I have connected to the, from the bottom plus I have connected to the top plus. Bottom plus, from here bottom plus to top plus. Plus means red, minus means black. That is what I have used correctly. That is the first step. Then second step is the power and the ground. Now in the integrated circuit there is power and ground here. This is power, this is ground. Then we have to connect the power and ground in the second step. But wait, let me tell you. Now in this integrated circuit, this you see a dot. From that dot it will show that this is the starting point. Now, from the, you can connect it, the integrated circuit you connect from here, or you can from here to here, or from here to here. You can connect the integrated circuits power to the breadboard's top plus anywhere. Then from there it will give the power factor, it will get. Then from the ground, from the IC integrated circuits ground, you connect to the breadboard's bottom layer minus, or from anywhere here, because this is one port and this is one port. From here you connect here. This is your source. I connected from here to the breadboard's bottom layer minus anywhere. That is the second step. Ground means minus. Now the third step is switch connection. The connection of the switch. Now how do we connect the switch? The switch's connection is from the switches 2B, we connect it to the breadboard's bottom layer plus. Now what is 2B? Now in a switch there is 1B, 2B, 3B, 4B, and here also 1A, 2A, 3A, 4A, 1B, like that it goes. From here to here, like that it goes. Now from the, I have connected to the switch's bottom. Here you can connect. Now this switch is connected to the breadboard. Sometimes the switch will not connect to the breadboard and the project won't work. If the switch is not connected to the breadboard, it will not work. Connect the switches 2B to the breadboard's top plus, then the other part, you connect to the breadboard's place again like this. Then what you do is connect the scissors from the 1A to the integrated circuits. Input A you connect like this, and from the scissors to A you down here anywhere you can connect to the integrated circuits. Input B. That is the third step, switches connection. The fourth step is the lamps connection. The lamps is an output device. That is why we connect it to the integrated circuits output. Now connect the lamp terminal 2 or terminal 1 to the bottom layer of the breadboard's bottom of the breadboard minus. Then from there you connect and wire from the bottom, from the breadboard's bottom minus to the integrated circuits ground. Okay, and it has to be black because ground is minus and minus is black color. Then that is why we are attaching it to the minus. Then connect these light bulbs terminal 1 to the resistors terminal 1, and from the resistors terminal 2 you connect it to the integrated circuits output 1. That is the fourth step. The fifth step is to set the truth table. Now in the truth table we already know what will happen if start simulation, and if both of the switches are off, the light bulb will be off. Then if one is on and other one is off, it will not work. If one is on, if one is off, okay, now it will not work. It will work because both of them are on, it will work. Now one is off and other one is on, it will not work. One is on and other one is off, it will not work. Only both of them on, it will work. The light bulb will be bright. That is how it does, and it tells, and the power supply tells how much voltage it is. It is giving, because if we give lot of voltage, the light bulb will explode and integrated circuit will go. Now I am going to do this circuit design without seeing. Let me first delete everything. Now the first comment we need is very important, and it's the breadboard. Without breadboard it will be difficult, and I am going to use small breadboard. Move it to a perfect position. Next what I do is get an integrated circuit IC. I will type, otherwise it will be in the down, very down you go, and you will get this. We just need quad and gate. We need quad and gate. Next comment we need is light bulb. Output, and let me rotate. Next we need resistor. We need Swiss, any type of Swiss, but I will just going to use this is input. I am going to use DI pieces. Next what I need is power supply. You can get it from instruments. Then those are all the components. Next, you have to do the program. You have to make sure they are all in the correct place. Now let's do it. The first step, you connect the power supply is positive to plus here. We change the color. Then the power supply is negative. We connect to breadboard's minus. Change the color. Here I will connect. Now from here I connect to minus. And from this place I will connect. Change it red, and that is the first step. The second step is to connect the integrated circuits, power and ground connection. The power will connect plus, ground always minus, and color will be black because minus is black. That is the second step. Next, the third step is the Swiss connection. From the Swiss we will connect to, from here we will start. From the Swiss's bottom 1A, we connect to the integrated circuits input A. I will change color to any. From the Swiss's 2A, I connect to integrated circuits input B. Now I need Here I need to delete and connect to plus. Now I click start simulation and the bulb is working. Let's see. Okay, not working. That means both are on, it is working. One is on, one is off, not working. One is off, another one is on, not working. That means two are off, not working. That means mine is correct and two are on, it is working. Thank you everybody for watching this video. Hope you guys like this video. Don't forget to like and subscribe to my channel. Bye. See you guys in the next video.